This is going to be a 3-part series on electrolysis, with 3 levels of complexity starting from a basic, somewhat impromptu setup, to an average laboratory setup, and finally, a remote access lab suitable for students studying from home. Given the current online teaching situation, and considering it might become an usual thing, the 3rd part containing the remote lab setup should be the most interesting to any and all participants involved in online learning. The purpose of this series is to demonstrate the usefulness of these types of videos and setups for educational purposes, more specifically, using them as complementary to lectures in an academic setting. Electrolysis is a process in which current is passed through a substance to set off a chemical reaction. In water, the current causes the water molecule to split into hydrogen and oxygen. Building on the ideas of Volta and Galvani, scientists like Faraday were able to figure out how electrolysis works and use it for various purposes. It was useful for understanding electricity and even discovering new elements. Here's what we'll need for the experiment. As a power source, we will use a 9-volt battery. We will use 2 pencil LEDs for the electrodes. And we'll need some wires to connect our electrodes to the battery. For a better practical experience, we'll need some salt. Adding salt to the water will make for a better conductor of electricity. The salt will split into sodium and chlorine ions, which are very good at carrying current. We'll start by filling a glass with water and adding some salt. We then mix it until the salt dissolves. Don't worry about the exact quantities, as this is just a proof of concept. We put the pencil LEDs in the water and make sure they stay put using some crocodile clips. We then connect the black wire to the negative terminal of the battery and the red wire to the positive one and make sure that they do not touch. And now both of our electrodes are connected to the battery. Immediately, we should see gas being produced at the electrodes. We can see that there are more bubbles forming at the negative electrode. This is because those are hydrogen bubbles, and there is twice as much hydrogen in water than oxygen. For our second part, we'll have a more rigorous laboratory setup and we'll take a more in-depth look at the experiment. Thank you for watching!